Welcome back to my channel, everyone. 3 Tips here, and I've been doing some refining here without the camera. It's been like taking a breath of fresh air. I've got some metallic gold that formed down inside this chloroauric acid solution. Little bits of metallic gold. This is about 4.5 troy ounces of pure gold. So now I'm going to pour this into the ice, and then we're going to precipitate this with some sodium metabisulfite. I just wanted to do a quick video here to update folks on what I've been doing. Been way backed up on all of my refining, all of my silver and gold refining operations. I'm all backed up, so I put the camera down. I promised Mrs. 3 Tips I'd put the camera down and get caught up on some of this stuff. So that's what I've been doing. But I did want to demonstrate precipitation here. Should be about 4.5 troy ounces of pure gold. And now what we're going to do is grab some sodium metabisulfite here. Here it goes. Ready? This is always neat to watch. I never get tired of watching pure gold precipitate out of an aqua regia solution. It's just fascinating to watch it happen. I've still got my platinum experiment. Here it is. Here's our platinum precipitate in this funnel here. I'm still going to do a part 3 on this. Just haven't had time to get to it yet. But I wanted to include this precipitation as a separate video. It's always neat to watch gold precipitate out of solution. It's full of ice. Beaker's full of ice. This is ice that's been made from tap water. And I'm going to keep going. You can see there's solution's still got a yellowish tint to it. Look at all that gold down there forming down on the bottom. Let's see if I can get that in there for you. See that right down here? It's all pure gold powder forming on the bottom of that beaker. All right, let's keep adding some sodium. You know what? Let me do a Stannis test on this right quick. Show you what the gold looks like in solution. I can still tell that there's some left in solution by the color of the solution. This is just Stannis chloride testing solution. Put a drop. I got some of the solution out of here on a piece of filter paper. Now I'm going to add a drop of Stannis chloride testing solution. You see that dark stain? That's an indication that we have gold yet in solution. So I'm going to keep adding spoons of sodium metabisulfite until we get all of this precipitated out. There's that white foam. You see that white foam that forms on top? And that tells me that we're complete with the precipitation. Now what I'm going to do is reach in there and get another Stannis test, verify that we've got all of the gold precipitated out of this solution. And there you see no reaction on the end of that piece of filter paper from the Stannis test. That tells me that all of the gold has been precipitated. You can see the gold down at the bottom of the container down there. Like I said, that's about 4.5 troy ounces of pure gold. I've got some gold here in this flask, and I've just filtered it. I've precipitated 3 times, and this will be the 4th time that I dissolved it. I made the mistake of throwing some dental scrap in with this batch of gold, and now I'm having platinum group metals follow the gold as I precipitate it. So what I'm going to do now is up here I've got a stir bar prepared. I'm going to add some distilled water to this, and what we're going to do is dissolve some ferrous sulfate, Copperas, and use ferrous sulfate to precipitate the gold. I'm going to turn the heat on here, and I've got some ferrous sulfate in a jar. I'm going to use this up first. I bought the ferrous sulfate on eBay, and Copperas is its non-scientific name, if you will, as it's spelled here. But I looked on eBay the other day to get some more, because I'm going to be running out here when I do this precipitation. And it's not called Copperas anymore. They call it iron sulfate. And so if you're looking to buy some of this, don't look under Copperas. It's going to be called iron sulfate. The reason I'm going to use ferrous sulfate here is because, according to Hoke's book, the Copperas, ferrous sulfate, will bring down the gold, all the gold, and nothing but the gold. Sodium metabisulfite has a tendency to bring down platinum group metals if they're present, and I suspect that they are in this batch here of gold down here, because of the dental scrap that I added to it. And if you look here, you'll see that I still have my platinum refining experiment here. I haven't moved forward with it. I've still got the precipitate. We'll be working on that next once I figure out what I'm going to do with this. But for now, what we're going to try to do is use ferrous sulfate to dissolve or precipitate the pure gold from this solution. I don't know quite how much to use here, so what I'm going to do is just make an excess in this solution. Here's what it looks like. It's just a green powder. And I'm going to add some more to my beaker here and see if we can get a bunch of it to dissolve. Because, like I said, I got a pretty good sizable amount of gold here. And I don't quite know exactly how much Copperas to use. Like I said, one of the advantages is it'll bring down just the gold. The disadvantage is it's kind of cumbersome to use it. It's not as easy as SMB is, but SMB, sodium metabisulfite, will bring down platinum group metals if they're present, and I suspect their presence here because I did the dental scrap in with this batch. Okay, I think I've got as much of the Copperas to go into solution as I can here. I'm gonna add just a little bit more water to make sure we get a nice dissolve on that Copperas. I changed the beaker out down here to a 4-liter beaker. I've done this in the past and run out of room, so I didn't want to just use a 2-liter. I'm using a 4-liter beaker. We'll add the gold to this 4-liter beaker, and then we'll filter the Copperas solution in on top of our gold solution and precipitate the pure gold with the ferrous sulfate. This has been on heating now for about 15 minutes. I'm going to turn the heat off. What we'll do now is you'll notice that the ferrous sulfate solution is a brown color. I'm going to add some hydrochloric acid here. And this should turn the solution green, which is what we want to see. Here we go. Should turn it green. All right, I've probably got a ½ pound to 3/4 of a pound of copperas dissolved in here. What I'm going to do now is I'm going to set up the funnel down here, transfer our gold solution. It's been filtered. You can see it's crystal clear. I'm going to transfer it into this beaker. One nice thing about precipitating with Copperas is it doesn't produce any fumes like the sodium metabisulfite does. Got to filter the Copperas because it contains tiny bits of iron that will contaminate the gold. So now I'm going to start pouring in the Copperas into, let's just start pouring it in. We focus down here on the beaker. Here it goes, man. I'm going to pour this in now. It's warm, but it's not hot. Here we go. Here goes our first splash into the filter. Should see the gold start precipitating immediately. While we're waiting for this gold to precipitate, I want to come over here and show you right quick. This is the silver solution that's cementing on copper. This is the silver that I used to inquart that batch of gold with, that had the teeth in there with it. And you can see there's black material cementing out with the silver. That black material, see that right there? That black material is the platinum group metals coming out of solution onto the copper and on the silver. So if you ever decide to do a batch of gold and you got teeth, dental scrap, I'd recommend doing it separately from the carat gold that you have in your batch.
It takes a lot more time, produces a lot more waste than sodium metabisulfite, but the ferrous sulfate will drop only the gold and leave the platinum group metals behind in the waste solution, giving us a good separation of the gold from the platinum group metals.
I've added all of the coppers from that last amount that I dissolved. As you can see, I've still got lots of gold in solution. So now what we're going to do, I've got to make some more copperas here. So what I'm going to do is add some water. And then I'm going to add some more of the ferrous sulfate and dissolve some more. and keep adding Copperas until I get all the gold to dissolve. I've used every bit of the Ferrous Sulfate. If you look over here, you'll notice that I got just a little bit left in my beaker. So I just made it. And so now I'm going to do a quick Stannis test here and make sure we've got everything out of solution. All the gold has come down. And there you can see all of the gold has precipitated now. Got all the gold precipitated. I'm going to pour off this waste solution now into this large beaker, and we're going to collect our prize down at the bottom of this beaker. Oh yes, look at that pretty, beautiful, pure gold powder. Oh, sorry about that last clip. I didn't have the camera oriented correctly. I'm going to take a quick Stannis test just to make sure that we've got all the gold out of solution. And there you can tell by that test, it's negative for the presence of gold. Might have a slight orange color to it, which indicates we may have some platinum or palladium in solution. Give it a quick rinse with some hydrochloric acid here. Try to get all that iron rinsed off of there. Should rinse off fairly quickly and easily. Let me get in here and rinse down the sides of the beaker. There's gold clinging to the sides. I'm just going to rinse it down into the main clump of gold down at the bottom there so we can get it all rinsed out real good. Comes off very easily. Got most of it rinsed off now. I'm just rinsing it with water, and we'll add that to our waste beaker here. It's getting there. A little bit of the gold's getting poured over into this waste container, but I can recover that later. No problem. Now I'll transfer the gold into a smaller beaker so that it's easier to work with. Yeah. I don't know about you, but that does not look like 4.5 troy ounces of gold. Just going to keep rinsing it here until I get all of the yellow color out of the gold. The yellow is the Copperas, or the iron that's in there. Still see a yellow tint to it. Got to keep rinsing until all that yellow is gone. I've been rinsing the gold now with hydrochloric acid for at least a half an hour. Probably had 20 or 30 of these rinses. And you can see we still got just a slight tint of yellow there. So what I'm going to do is continue to rinse until the hydrochloric acid stays completely colorless. I'm going to add some boiling distilled water now. I'm going to start rinsing with boiling distilled water. I don't know about you, but this certainly does not look like 4.5 troy ounces of gold. I've got the gold rinsed free of iron, and to verify that, what I have is some ammonium thiocyanate. This is a very sensitive test for iron in solution. I've got some of the ammonium thiocyanate in each of 4 of these spot plate cavities. What I'm going to do is reach up here, grab some of the solution out of our waste, and just show you what kind of reaction we get when we put a drop of that waste on that ammonium thiocyanate. You can see it turns a dark black to red color. Show you how sensitive this test is. I'm going to add the rest that's in this dropper to this sample of water. Mix it up real good. That's about 22 milliliters. I put 2 or 3 drops of the solution in there. I'm going to drop it on some ammonium thiocyanate here. You see it turns bright red instantly. All right, to this one I'm going to add a few drops of just plain water. And you'll see that there's absolutely no reaction there. It didn't turn color at all. I'm going to reach down into our rinse water here and put a couple drops in this cavity that has ammonium thiocyanate. If there's any iron in there, we should see a color reaction. Here's the waste, turned almost black. Here's a highly diluted sample of the waste, turns red. Back here we've got a sample of plain water, clear and colorless. And then here is the sample of rinsed water that we took off of our gold. And there's just a tint, a slight tint of redness. So that means we've got a little bit more rinsing to do. I've got all of the iron rinsed off of the gold now. What we're going to do is we're going to transfer it. Let me pour some of the liquid off here. I'm going to put the wet gold right down into this melt dish here. If that's 4 troy ounces, I'll eat my hat. Now what we'll do is we'll move this over to the melt table here and go ahead and start melting.
I'm shooting this footage with my GoPro, and I've got it shielded behind a welder's helmet so that you can watch what's going on. The flame is usually much too bright just to use the regular lens focused on that melt dish. So this gives you a good vantage point, a good view of the metal being melted. And I got to be honest, I was very concerned about the amount of gold that was going to come out of this refining. That I calculated that I had about 4.5 troy ounces, but it sure did not look like it when I had the gold mud in the beaker. I must say that I have seen this before, where it looks like the amount of gold in the beaker, it looks like you got ripped off or something, and then it turns out to be the proper amount. There was a little bit of a skin forming on the thing there, so I hit it with some borax right there, a pinch of borax. And then I hit it right here with a pinch of sodium carbonate, and then another pinch of borax, and another pinch of sodium carbonate, and it came out just beautiful. The skin on top of the molten gold just cleared right up. And if you watch right here, this is one of the best money shots that I've ever taken, pouring a bar here. Just really fascinating to watch this. And then you'll watch the bar freeze. Unbelievable. So cool.
All right, here we go. Moment of truth. See how this bar is going to look. Let's get it up off of the out of the mold here. It's pretty nice. Oh, wow, look at that. Very nice. Oh my goodness, it came out mirror finish. Just beautiful. Good Lord. I always gawk at it when it comes out looking real good like that. Just beautiful. And it looks like it might be 4.5 troy ounces. I would have never thunk it. Well, here it is. Our beautiful bar of 24K, absolutely pure gold. I never get over how beautiful the metal is when it's this pure. Most people never get to see gold this pure. And now for the moment of truth. Let's see what we got for a weight on this thing. And look at that. I got 4.59 troy ounces. I never would have believed it. With that little bit of mud that was in the bottom of that beaker, produced this beautiful 4.5 troy ounce bar of pure gold. All right, this will conclude the video. Thanks for watching.